Hi everyone, welcome to the last part of this course. And first of all, huge congratulations to all of you to finish all the 10 chapters. Hopefully, you have thoroughly enjoyed the chapters, and I also hope that I was able to convince you, motivate you why this is an important course, not only in terms of academic purposes, but also for your research purposes, right? And whatever we have discussed was just a small part of a huge area that is evolving every day. So let us together conclude this course. So what I will do today, I will briefly talk about the gist of all the chapters that we have discussed right here. So we will try to answer three questions: what, why, and how, right, for individual chapters. So let's start with the first chapter. The first chapter we discussed networks and society. So this was basically an introductory chapter where we basically wanted to understand how social network can be visualized, can be conceptualized using any data set that is given to us, right? And and why this was important, because analyzing these networks provides interesting insights about the problem space that often would have been unexplored otherwise. So the beauty about network structure is that it gives us strong understanding about the interrelations, and these interrelations, if you do not know the interrelations between entities, objects, right, as a whole, right, so the problem would be that we won't be able to understand the big picture, right? Micro level statistics is okay, if you look at the macro level statistics, you won't be able to understand if you do not have the interaction behavior. So therefore we decided that we will discuss a set of sophisticated algorithms to understand the social network structure. In chapter 2, we discussed different measures, right? So a network possesses different properties based on the spatial structure of it, which needs to be analyzed. And why this is important? This is important because because we wanted to extract information from large scale networks. Now we wanted to understand micro level, meso level, and macro level statistics, and we discussed various types of properties: node centric, link centric, right, subgraph centric, even graph centric properties, right? So hopefully you remember metrics like page rank, right, clustering coefficient, degree centrality, betweenness centrality, eigenvector centrality, right, card centrality, and so on and so forth. In chapter 3, we then started discussing on how network evolves over time, the growth pattern of a network. Now why this was important? This was important because if you see how, sometimes what we do to analyze certain things, we scrape data, right? Now scraping Twitter, for example, or scraping Facebook is extremely challenging, right? So if we can have some sort of synthetic process, right, some sort of synthetic process to generate network, and then we apply all our algorithms on the synthetic networks, and then if those algorithms perform well, then we can basically map, we can use those algorithms for real world data set. So in order to create a real world like network structure, we tried to understand different types of network generation models, as simple as models like random graph models. Then we have looked at sophisticated models like Barabasi-Albert models, right, which was basically inspired by, say, Price model, and even other preference determinant models discussed earlier. At the same time, we also discussed like vertex copying models and so on and so forth. And we tried to realize that if we generate networks using this process, right, would it be possible to, say, preserve properties like clustering coefficient, properties like power law degree distribution, properties like 6 degree of separation, and so on and so forth, right. And we have seen that few models preserve few properties, other models preserve few some other properties, but there is no such universal model which is able to preserve all sorts of properties. Okay. Then we we moved into the details of links, and we discussed link analysis, right. So link is an important ingredient of a network, links or relations, right. So and depending upon how links are formed, we see properties like communities, we see properties like say gateways or gatekeepers, or say bridge between communities, and so on and so forth. We we got motivation from social science. We discussed strong ties, weak ties, right, sign network, status theory, balance theory, and so on and so forth. And then we tried to understand how to measure an importance of a link. We looked at page rank, we looked at div rank, and other types of measures like seam rank, and so on and so forth. So these measures are really important in cases like say epidemic spreading, when you want to cut a network, right. What would be the minimal way possible to disconnect a network, right, by removing edges, right. So this kind of metrics are useful in those applications. Then we looked at community structures or clusters in a graph, right. Communities are roughly defined by sets of nodes which are strongly connected internally and sparsely connected externally. We tried to understand how to quantify a community. Community is an ill-defined problem. So people have tried to come up with multiple metrics to quantify communities. We have seen metrics like modularity, right, permanence, CART, right, and we also looked at different types of community structures, disjoint communities, overlapping communities, hierarchical communities, local communities, and so on and so forth. We also looked at how to measure the accuracy of a community detection algorithms using metrics like NMI, purity, and so on, right. The community structure is extremely important in applications like recommendation system, right, applications like viral marketing, applications like say churn prediction, and so on and so forth, right. So we looked at metrics. We also looked at how algorithms are designed to optimize these metrics to detect the community structures. Okay, disjoint community is still easy to detect, but when it comes to overlapping community, it is difficult. And we also looked at generative models like BCLAM types of models, which basically try to generate networks by constructing communities underline, and then we and as a byproduct we get the community structure. Okay. So then we looked at link prediction, and this is extremely important in the context of recommendation system. Missing link, future link, we try to understand the difference between these two applications, and then we looked at different ways to predict links. We started with simple statistical measures like Jaccard coefficient, atomic adder distance to predict whether two nodes are going to be connected. We also discussed even sophisticated methods, right? Methods like methods which use random walk based approaches, right? Random walk with restart particularly to predict links. We also looked at probabilistic methods like to predict links. Okay. So in chapter 7 we discussed how cascade evolves over time, right, how cascade grows, particularly in the context of epidemic spread, right. We basically studied information cascade that can help us model the flow of dynamic information in networks. It explains how information such as virus, rumor, fake news, etc. Spread over the network, and how can we come up with preventive mechanisms to stop the spread of such information, information or misinformation. It can also be epidemic. And we discussed two types of methods, decision based methods and probabilistic methods, to understand the spread of such information on social networks. Now, this is useful not only to understand the dynamics of such spread, but also to come up with preventive mechanisms to stop the spread of such information. Okay. Chapter 8. In chapter 8, we discussed anomalous behavior, right. We again, anomalous structure of a network is an ill-defined problem. So, it depends on the context, the particular application that we are interested in. And we looked at anomalous nodes, anomalous edges, anomalous subgraphs, anomalous structure in static network, in dynamic network, in temporal network, anomalous structure with respect to the overall graph, anomalous structure with respect to a particular community, and so on and so forth, right. And this is important for many applications like fraud detection, network intrusion detection, and so on and so forth. So, we discussed method like oddball, autopart. We also looked at generative methods like, right, and so on and so forth. In chapter 9, we elaborately discussed graph representation learning. We started off by understanding neural networks, basic neural networks, and then we looked at machine learning and deep learning based methods for graph representation learning. We looked at methods like deep work, node to wake, GCN, graph neural network, graph convolutional network, graph attention network, and how these methods are useful for coming up with representations of nodes and edges, right. And these representations are then fed to the downstream task. The task can be, say, node classification or link prediction, right. So, and the last chapter was basically application, and we looked at how all the other chapters that we have discussed, how those things can be applied to 3 applications. So, first one was more about frauds, right, sock puppets and collusion, collusive activity detection in online social network. We also looked at recommendation system, particularly pin sage, right, how graph sage kind of methods can be used for recommendation system in platforms like Pinterest. And then we also looked at different models for COVID-19 spread modeling, right. So, some additional resources, if you are really interested in taking this thing forward and do some interesting research projects, these are the links that you should possibly look at. Here you will get lots of data sets, open projects, existing projects, baselines, codes, and so on. So, the first one is of course the SNAP Stanford network analysis project by Urel Escobic. You will get whole bunch of data sets and codes that have been designed for different applications of graphs. UCI data set is also very useful for different purposes. You have other network repositories. You have this Connect project where you will get a lot of data set. This is another link. This was nicely mentioned by Professor Aaron Closet. You will also get different types of data sets, and of course, the other Git links, including our links, our Git link. We also provide a lot of data sets for different applications, right. These are some of the visualizations tools that you can use to visualize your network, right. JFE, right, linkage, node goat, and so on and so forth. And of course, since you have already done a lot of your assignments, so you are already aware of this Python packages, right? These packages are really useful for different applications. So this brings us to the end of this chapter. Hope you have enjoyed this thing thoroughly. If you are interested to contact me, please feel free to send your email to this email ID, chak.tanmoy.iit@gmail.com, or you can even look at our website LCS2, right? You will get other opportunities, other ways to connect our lab and connect with me. If you if you have any other suggestions to improve this course further, please feel free to get back to me. Thank you very much, and I hope this course has motivated you to take this thing as your next set of for your next set of projects. Even this would also help you start a new career on network analysis. Okay, with this I would like to thank all of you, and once again congratulate you all to to be a part of this nice course. Hope to see you sometimes physically. Thank you very much.